Welcome one and all to the greatest lens show on YouTube, another David Hancock channel lens showdown. Today's exciting feature includes 3 vintage Olympus Zuiko lenses, the 28mm f2, the 28mm f2.8, and the 28mm f3.5, making yet another show on this channel. These are slightly different lens designs, much different maximum apertures, and what we'll find out today is if that means they have different performance profiles. Our 3 contenders originate from different eras of lens design, with the f2 and f3.5 being early 70s releases and the f2.8 arriving 10 years later. Will the advancements in lens engineering in that time make a difference? Does a faster lens mean better or worse performance? Drop me a comment and let me know how you thought these would rank and if you were right. The specs on these are all pretty darn close to even, with the only important variations being the aperture range and the element and group counts. Your focal length and angle of view are 28mm and 75.4 degrees on full frame and film, though the 3.5, as we'll see in some of the later test photos, does capture a slightly wider scene than the other 2 lenses. Element and group count also varies by lens, but of note the f2 apparently, according to lensdatabase.com, includes a floating element system. The closest focus is 0.3 meters for all, which in the US is 1/2 of 1% of the current longest ever American football field goal. The weight also varies very slightly by lens, and I used a digital scale to get specific weights for all of these lenses because the online resources really seemed wrong. And they were, but at most they were off by 2 grams, so they weren't that wrong. The diagrams here are interesting in that they show how the lenses have such different weights, but also show how 3 different lenses of the same design type, which is retrofocus, can be designed differently. The 2.8 is an outlier here in that it has a large air gap at the front, and the others use lens pairings instead. Anyway, it's always interesting to see how slightly different optical designs perform, and if there are performance advantages to different approaches. Sharpness in the middle, as gauged by the DOTS test chart, is remarkably better with the slower lenses versus the 2.0. Between the 2.8 and the 3.5 seems a hair sharper to me, though the performance is hard to distinguish. The corners tell a different story, with none of the lenses having sharp corner dot performance. In these sample shot compilations, taken wide open at about a 1/2 meter from my hiking boots, the center sharpness on the boot texture appears slightly better, but not by much, on the 2.8 versus the 3.5, with the 2.0 having a good deal of spherical aberration-related softness. By f5.6, however, all 3 lenses have, to my eye, the exact same sharpness in the image center. At f16, I'd give a slight edge to the 2.8, and for this category overall, I'm going to rank them 2.8, 3.5, 2.0. Build quality is kind of a gimme category here, as all are made in the same basic manner and handle similarly. All are equivalently good and tie for first. The contrast is affected on the f2 by spherical aberration, which at the wider apertures saps contrast, like seeing an upset ex-girlfriend on your caller ID saps your excitement for life. But otherwise, the lenses perform in a highly uniform and similar manner. To that end, the 2.0 takes last only because of the slight contrast reduction when the performance is a bit glowy at the wider apertures. Star quality is ranked at f16, as only the 2.8 lens has an f22 setting, and honestly, across the board point source stars were their best on each lens at f16. The f2 has 8 pointed stars with clear spikes and good definition. The 2.8 and 3.5 have 6 pointed stars, and the 3.5 offers up stars which are slightly cleaner. To that end, the f2 takes the top slot and the 2.8 the bottom. Distortion performance was interestingly dissimilar. The 2.0 had noticeably more line bending in the image than did either the 2.8 or the 3.5. The difference between the latter lenses came down to a matter of pixels along the centers of the yellow lines as they related to the bend towards the corners. The 3.5 edged out the 2.8 here, though in real-world use, someone with a much keener eye than I have would be needed to discern a difference between the 3.5 and the 2.8. Light loss is present in each lens across each aperture, though in real-world shooting I don't see it as something that detracts from an image at all, ever, with any of these lenses. The light loss is a pleasant and smooth gradient for each of these lenses, and this ranking comes down strictly to the amount of light loss each lens exhibits. To that end, wide open, the greatest apparent light loss comes from the 3.5, with the least from the 2.8, and the difference could affect lens choice for photographers who haven't discovered that the aperture ring moves. At f8, the story is markedly different, with the f2 delivering the least amount of light loss and the 3.5 the most, but the differences here are substantial. Going to f16, the story continues in this vein, and it's apparent that the f2 lens has the best performance in this category as it stops down, and better performance at the same apertures versus the other two lenses. Flare was present in each lens in different ways. The f2 had streaking and small color patches, while the 2.8 had similar, larger patches and rainbow flare at certain angles. The 3.5 exhibited large areas of color veiling flare, and the 2.0 here had a commendable performance in this regard, and the ranking is going to follow the aperture sizes. Ghosting is a similar story to flare, with the 2.0 having tiny little baby ghosting dots. They're so cute. The 2.8 delivered larger and more diffuse ghosting patches with some ghosting cones, and the 3.5, as we discussed in the previous two videos that featured this lens, farts out rainbows like Nyan Cat and fills the images with cones and circles. As with flare, the ranking here follows the apertures. We'll jump here into the Zidal analysis, and for this video I did retake the f3.5 test shot, which had been used in the previous two videos about this, so new photo here. And I did that to ensure all three lenses had the exact same exposure settings within the camera, and that the framing and positioning of the lenses and camera were identical. The 3.5 exhibits a slightly wider field of view versus the faster options, and that indicates a slightly wider than stated angle of view, though not in a consequential manner. All of these test shots were taken at the 0.3 meter close focus point for each lens. Center sharpness on the 2.8 and 3.5 were both exceptional, with some softness in the 2.0 that stems from a slight spherical aberration near the middle, which gives way quickly to a mix of minor coma, astigmatism, and field curvature all at once. We can gauge this, by the way, by the shape of the blurry dots near the center crosshairs, as well as the direction of the blur, which, in a lens absent field curvature, would be expected to point outward from the center. The 2.8 exhibits completely insignificant chromatic aberration in the center and some exceptionally well-corrected astigmatism. The 3.5 exhibits no aberration of note and is also sharp enough to render the pixels on my monitor. In the corners, all lenses performed identically to themselves in each corner, so we'll just look at the top left here. The f2.0 is unique here in the blur profile because it exhibits sagittal astigmatism as the major issue. And the astigmatism is quite pronounced, and it also absolutely affects blurry areas in real-world use. And as a secondary note, the 2.0 has chromatic aberration on the order of a couple of pixels on this 7008 pixel wide image, so really a non-issue. The 2.8 and 3.5 both exhibit characteristic cat eye blur that we've seen multiple times in the series. In fact, we've seen it so often that I've been looking to identify the cause of this and ascertain if it really is a mix of coma and astigmatism, which up till now is what I thought it was. After reading the chapter on aberrations in the absolutely wonderful optical engineering book, A Focal Manual of Photo Technique by Arthur Cox, in the 13th edition if you're curious, I believe that this blur pattern is zonal overcorrected spherical aberration combined with projection angle. I believe this is the case because overcorrected spherical aberration results in bright perimeters on source point lights which are out of focus, and lenses also project a cat eye shape toward the periphery of images, and that's just part of projection angle. These dots look like cat eyes with bright perimeters. This theory is supported with these light point test shots taken at close and infinity focus that show that the 2.8 and 3.5 do have overcorrected spherical aberration in out-of-focus areas, and they also show how circular blurry areas become cat-eye shaped toward the perimeter of images due to projection angle of the light. Handling was the same for each lens. The build quality is comparable, they have the same amount of focus damping, and the aperture rings are all equivalently well detented. The only difference between these lenses is the f2.0's grip, which is wider than the other lenses. But each lens makes the optimal use of space available, so I'm going to rank each of these in first place. It's just another gimme category for them. Breathing is very close across the board, so I had to measure the breathing in pixels. Here are the results. The f2 came in at 117, the 2.8 at 96, and the 3.5 at 106 on an image 4,672 pixels high. That's a spread from top to bottom of 0.4% and a between lens spread of 0.2%. We're going to call that identical, as it's entirely possible that my measurements were very slightly off. But even if they were perfect, who really cares about 0.4%? The apertures are all stepped at full stops, with the asterisk that the 3.5 does not have an f4 stop. Front elements are all non-rotating, but do move in and out 3.5 millimeters, and it should be a shock to no one that they all move in and out the same amount, as these lenses have the same closest focus point. Focus throws 90 degrees on the 3.5 and 95 degrees on the other two. Focus rings are stationary in that they do not move forward and back as the focus racks. Autofocus noise is NA because these are all manual focus lenses, and one of any of these three lenses in good shape should make no noise when being manually focused. So I went into this expecting that the 2.8 would absolutely dominate the competition because it's a decade younger, and improvements made in lens design from the late 60s into the early 70s for that 10 years were quite substantial. I also expected the 3.5 to arrive a close second and the 2.0 a distant third. Using golf scoring, the best possible score is 10 and the worst possible is 30. The 2.8 did win with a score of 16, but the 2.0 and 3.5 tying at 18 was a huge surprise. Now, each lens had different strengths and weaknesses that all balanced out quite well in the end, and ultimately each lens has a different ideal user. If you want a lens with minimal center aberrations and optimal sharpness, for instance if you're a micro four thirds user, then the 2.8 is your choice. If you want a lens with better flare, ghosting, star shape, and light ray roll-off performance, and especially if you shoot full frame so all of that softness is minimized in your enlargements, then the 2.0 is your choice. If you want a lens that's going to show up to your party wearing nothing but a fluffy pink boa and showing off years of accumulated drama, then the 3.5 is the one you want. For the cost differences between the lenses, and as of this video's recording, each lens is approximately double the cost of the next slower when looked at on the used market, then it becomes a question of budget. Will the 3.5 disappoint versus the 2.0, considering that my 3.5 was something like $160 cheaper? That's a definitely not for me, by the way. So overall, if you want one of these three and want to know which to choose, think about the performance characteristics that matter the most to you and select one that aligns with those characteristics and your budget. Ultimately, none of these three lenses is likely to be a greater success or disappointment compared to the other ones, and that's especially true if you use it in a way that sets it up to succeed the best that it can.